Well, good morning, everyone, and welcome back to Space Tech Expo Europe 2024. I am here with my friend Radim Badsi, the CEO of Groundspace. And you just told me a very interesting story. This is something that I had not heard of, but tell me about Groundspace.
Good morning. So at Groundspace, we focus on the monitoring of satellite constellations such as Starlink, OneWeb, but also all the upcoming constellations. So one of the challenges with satellite constellations is that they share frequency spectrum with all other communication satellites. We have a narrow window through the atmosphere, and so it's becoming quite crowded.
This is a very heavily regulated topic. The ITU is on top of this. But what you told me is that these signal beams get into each other's way, and satellites have to switch on and off their transmitters.
Absolutely. So you're right. There is a system, an international system of rules and regulations who has priority to transmit. But this sometimes conflicts with commercial interests. There are also technical challenges in coordinating with each other. So in practice, we're starting to see that it's not the rules are not always applied as they should be.
So now you measure or you monitor the activity of satellites. Tell me what exactly you monitor. What does that mean?
All right. So we look at signals transmitted from satellites to make sure that, well, first of all, that they're authorized. So this means that sometimes, if a satellite is not licensed in a country, they're not supposed. It's not supposed to transmit. But we also check power levels. We verify whether they comply with the frequency plans, like if they transmit at the correct frequency.
Okay, and there's rules for who has priority over who. Tell us a little bit about that.
Yeah, it's essentially on a first come first served basis. So in most of the world, to give you an example, OneWeb has priority over Starlink. This means that if you have a Starlink satellite and a OneWeb satellite in the same spot in the sky, OneWeb takes priority. So to explain it in simple terms, imagine like you're in a room with a lot of people, and so if everybody speaks at the same time, nobody's going to hear each other. So you have different ways of handling this situation. People can either take turns, or somebody can have priority. We can be the speaker, and so it works pretty much the same way with satellites.
Okay, and you told me geostationary satellites, they have priority over everything.
Absolutely. So geostationary satellites, they were the first out there, but it's also a practical matter because if you have a parabolic antenna on the roof of your house, you can't move it. It's pointed towards a single satellite, and so everybody has to coordinate around it.
Right, and you don't want to be disturbed watching that football match on the other side of the world. You want it to be
So
continuous.
maybe like maybe that's not a big deal if you miss if you miss
miss a
your
goal or two.
goal, not a big deal. But look at countries like Indonesia that use satellite services extensively, like for the financial market. Like you look at an ATM in Indonesia, every single ATM has a satellite dish on the roof. So this means that if there's interference between satellites, this could disrupt financial markets. It could have very serious effects.
Okay, now we're looking at the map here of the sky above one of your antennas. I think this is the one in France.
Yes.
And we can see the green ones are transmitting, the red ones are not. How is this information useful?
So, well, first of all, this is the first system capable of capturing this type of information. It is useful because we know, well, first of all, if a constellation or a satellite is not authorized to transmit, it should never turn green. It should never transmit. So we can get alerts, early alerts about this activity. But it is also important because if suddenly we see more green dots for a constellation, this could indicate that something's going on. So We have to remember that LEO satellite constellations are dual use. They have military purposes, and it can have a strategic importance to know that more satellites are transmitting than expected.
How much can you tell me about that? Because that's interesting.
So I mean, we've been hearing about the use of Starlink in the war in Ukraine, and I think it's caught everyone by surprise because Starlink, it wasn't designed originally for this type of purposes, but Starlink is used, for example, to pilot drones. They can be piloted without being seen. It's very hard to jam. And Also, Starlink is used for the coordination of troops on the ground. Could say like today, okay, SpaceX, then the United States have this capability. Tomorrow, it's going to be a lot of more actors. China, India, other countries are launching their constellations right now.
Okay, so we touched on two different types of use. One is for regulators to see if all these different satellites, mostly the constellations, are actually obeying the law, if you like, sticking to the rules. But there's also this strategic military use. What is your main customer? What are you focusing on?
We focus on three types of customers. First of all, regulatory authorities, who are really the police of the radio spectrum. They're the ones who coordinate spectrum use. They issue licenses to operators. Second type of customer, satellite operators, who want to know who's interfering with their signals, and they want to collect proof to show that that somebody is transmitting harmful, well, signals that are harmful to them. And third type of customers, defense and intelligence, people who want to have awareness of what is going on in the sky.
Exactly. Now, just to make that point very clear, you can see that a satellite is on. You cannot see what a satellite is on. You cannot read the signals.
No, this is, well, first of all, it's not our objective. But today, with the cost of encryption being so low, essentially there is no reason for satellites not to encrypt the data. So we could not see what is in the signals. That being said, we can still gain quite a lot of information just by looking at the signals. Frequency of how often they appear, power used, location, this type of information.
Even though you can't read the data, there is a lot of information in the data that you can see, whether a satellite is on or off, and the level of power it's transmitting at gives away a lot of information.
Yes.
And that is super interesting. And I can see
Oh, thank you.
the applications of this exactly in the areas that you say. Fascinating story.
Thank you
I
so
was
much.
not aware of this, and seeing it literally on the map, satellites that are on and satellites that are off, that is very cool to see. So thank you very much, Radim, for showing us what's happening in the skies over Earth right now, and fascinating story. I'm curious to see how this develops.
Well, thank you so much.
Thank you.